Okay, so I first of all want to thank everyone that's joined me here today for being a part of this. This talk was originally scheduled for App DevCon, and I was going to be giving it on Friday, but of course that was postponed until September. By that point, this content will be fairly stale, so I figured why not, you know, in the spirit of the show must go on, why not have it online? So I appreciate you joining me and being a part of it. All right, so the talk will be on SwiftUI and Combine. We're going to SwiftUI and Combine all the things. There is a link, the bit.ly link that you see here, Combine Swift UI ATT, will get you a download. That'll be a project we're going to start in that starts as being a UIKit based app. So you want to go ahead and download that if you want to follow along and code as we change things. And I'll explain what we're going to do in a moment. Okay, briefly about me, just in case you haven't met me before, don't know who I am and why you'd be listening to me talk. I've been doing iOS app development and architecture for a little over 10 years now. I'm an iOS architect at Wayfair. I've also authored several books and video courses on Swift and Arc Swift, Combine, and other topics around iOS development. And I'm an Apple certified trainer for Apple's Swift and iOS developer courses, which you may not even know existed, but they do. Okay, so what's in store for this hour? The first thing we're gonna do is we're going to take a basic look at Combine. What is it? How does it work? What are some of the fundamental concepts there? Then we'll look at UIKit versus SwiftUI and Combine. What are the differences and how you would go about implementing functionality using the two different paradigms? We'll look at a typical SwiftUI view and each of the components that makes that up to give you an idea of what the anatomy of that is. Then we'll jump right into code and we'll spend the majority of our time actually converting this UIKit based app to use SwiftUI and Combine instead. We'll wrap up and I'll leave you with a few parting pieces of information and a couple of gifts if you'd like to learn more. All right, jumping right in. Let's just start off. What is Combine? Well, it's a framework for performing asynchronous operations. And we've already got lots of ways to do that in iOS. And so there are some differences and some improvements to this, I think, that I hope you'll agree with after you've gone through this if you haven't had a chance to check out Combine yet. One of the things that makes it different, though, is that it's declarative. So it's reactive, okay? We're using reactive paradigms, but that part of that also means that it's declarative. And what I mean by that is you'll write code that declares what you want to have happen, but you won't necessarily get into the nitty-gritty details of how to make that happen. This is a lot more evident when we look at SwiftUI, which is also a declarative framework. But just so you know, the Combine in and of itself is a reactive and declarative framework for performing asynchronous operations. That's sort of a mouthful, but that's what it is. It's a unified approach, meaning there's one uniform way that you'll perform these asynchronous operations using Combine. And that's consistent throughout the SDK, no matter what you're doing. To give you an example of that, we're looking at this data here, this mutable data, okay? And in order to work with this data using UIKit and traditional APIs in iOS, you're going to need to learn about and understand how to use all of these different frameworks and techniques and patterns, right? So you're talking about observing notifications and dealing with delegate callbacks and completion handlers and using GCD and/or operation queues. As well, you'll have timers if you're managing the time sequencing of certain events. So you'll need to work with all these different types of paradigms in order to implement all the features of your app. That's the UIKit approach. With Combine, we're dealing with immutable data. And that immutable data will flow unidirectionally through Combine and then to other parts of your application, like, for example, SwiftUI, where we can bind your combined data streams to SwiftUI view components that will automatically be updated whenever that state, whenever that data changes. So as I mentioned, Combine is pervasive throughout the iOS SDK. There have been APIs added for things like URL session and notification center, core data. I mentioned SwiftUI, and there's many more. So at its essence, what is Combine? Well, it's about publishers that publish events and subscribers that receive those events. And those events are also values. So you might be receiving just data in a stream, but there'll also be events that you'll receive and be able to handle or react to. So if we look at this over time, with these arrows pointing down representing time, the interplay between publishers and subscribers goes something like this. Subscriber is going to request to subscribe to the publisher. That's the first thing. Secondly, the publisher is going to give a subscription back to that subscriber. Next, the subscriber will request values from the publisher. Now, there are some built-in operators that you can use to create subscriptions. Sync and assign to are the two. And those automatically request an unlimited number of values. You don't actually have to explicitly say, I want to request an unlimited number of values. So this is a step that isn't often implemented unless you're creating a custom subscriber, which we're not going to get into today. But it's important to know that that's what's happening, and you are receiving an unlimited number. And you might have a use case where you need a subscriber that will only receive a maximum of up to, say, 3 values for some reason. And if that were the case, you'd create a custom subscriber. And what we're talking about here, this is called demand. And the process of managing that demand is called back pressure management. Again, we're not going to dive into that today, but just know that that exists, and that's a capability of Combine. So now that we have the subscription and the request for values has been made, the publisher can now send values up until the max number received, or unlimited in the case of the 2 built-in operators that I mentioned. This will keep happening until the publisher sends a completion event. And there are 2 types of completion events. One of them is a normal completion. In this little horizontal line here with the vertical bar, that's representing that it's a normal completion, and that's just the publisher saying, I'm finished. Once it sends that completion event, that finished completion event, it can no longer send any more values, and the subscriber knows that it's done. I should also mention too that a publisher needs at least 1 subscriber or it won't send any values either. So that's something to be aware of. So there's another type of completion event, and that is if there is an error. So a publisher can result in emitting an error, and if it does that, as it's represented by this red X on the horizontal line representing time, that would also mean that the publisher is finished and it can no longer emit any more events or values, but the subscriber can receive that error and handle it in some way. So when the publisher finishes either by a regular finished event or by emitting an error, it's done. It can no longer send any more values. However, a subscriber can also cancel its subscription by calling cancel. And so that tells the subscription to no longer send any more values to the subscriber. I'm done receiving values. More often than not, there are actually 2 ways that a subscriber can cancel. One is to call cancel, as I mentioned, but more often than not, you'll stick your subscriptions in a special collection that's called an any cancelable collection. And then when that collection goes out of scope, it'll automatically call cancel on its contents for you. So we're going to do this in code, but it's just good to be aware of, and you do want to do that, otherwise you'd be leaking that memory. So it's important, and you'll see we'll do this over and over again when we get into writing some code here. So we look at this another way, and actually even before I mention this, in between the publisher and the subscriber, in your subscription chain, you'll usually have 1 or more operators. And those operators will manipulate the values that they receive from the upstream publisher, and then they will send those manipulated values downstream to the subscriber. And if you have more than 1 operator in there, well, they're receiving values from the previous operator and sending the values to the next operator and so on until it gets down to the subscriber. So to see what that looks like, we're going to use something called a marble diagram, which is a pretty common way to learn about operators in reactive frameworks. And what we're looking at here is the horizontal lines represent time now, top one being the publisher, bottom one being the subscriber, and the vertical bar just representing a normal finished event. So this publisher will finish at the point that time reaches that line. In between the 2, we're going to use a map operator, and this works just like the map operator from the Swift standard library. It's going to receive a value, perform some kind of operation. In this case, it's going to receive an integer, multiply it by 2, and send that value downstream. So the publisher emits a 1, map receives it, does its thing, and emits a 2 down to the subscriber. Similarly, a 2, map will then yield a 4, and a 3 will yield a 6. Should be no surprises there. Okay, shifting gears a little bit. We're going to jump right into just kind of looking at what it looks like to do a typical task like fetching data and updating a UI using UIKit and traditional APIs, and then we'll compare that to what it looks like with SwiftUI and Combine. So typically you're going to fetch data, and let's just say that t-shirt represents that unit of work. We're going to decode that data, then we're going to update state, our model, for example, and then we're going to update UI. And so adding those t-shirts up would be roughly this size t-shirt amount of work. With SwiftUI and Combine, you do not need to manually update your UI. You'll be binding your UI to your state so that it'll automatically, and that's the declarative aspect of SwiftUI and how Combine interacts with that. So you don't update the UI. You remove the amount of work that you need to do, but that also eliminates a lot of edge case bugs, right? If you forgot to update a particular piece of UI, like a label based on a state change, then you would have a UI bug, essentially. Oh, so anyway, this is the unit of work that represents those 3 t-shirts for SwiftUI and Combine. Less work, same outcome, better outcome, less effort. So more practically speaking, if we're looking at, for example, a product card here, and this is a gnome that you can buy at Wayfair. It's actually an 8.5-foot gnome, and you can buy this. It's literally for sale. You know, and we have this model object next to it that just shows that we have a quantity of 0 of that gnome right now. So if we were to do a fetch, and we're going to then decode the data, and then we're going to update the state, and now we'll be ready to update the UI. So this will involve maybe updating the quantities label to 1, and probably want to set that out of stock to be either removed from the super view, or hidden or something like that, so we can not include the buy now button. However, if you forgot to do that, then we updated this card and the quantities changed, but we didn't update this label to remove it. And now we still cannot buy this gnome because we have a UI bug here because we didn't update the UI correctly. And of course, that doesn't make the gnome very happy. Okay, with SwiftUI and Combine, I'm going to just run this animation here in a moment, and you'll just see what will happen is we fetch, we decode, state's updated, and UI is automatically updated. That is the beauty of SwiftUI with that declarative syntax and that binding of Combine to SwiftUI, which of course makes the gnome pretty happy if you do decide to spend the money to buy him. He's not cheap. All right, I'm going to jump into just a typical example of what a SwiftUI view would look like. We're going to look at the anatomy of this, and we're going to go right down the list here of all the components that you see here. And then we're going to write code very similar to this in the actual project we'll be working in momentarily. So from the top, first thing we notice is that a SwiftUI view is a struct. Okay, it's a value type. Now that's not to say you couldn't make it a reference type. It would have to be a final class. It can't be subclassed. But I haven't found a good reason why you would want to. And so when you do create new views using the new file wizard or start a new SwiftUI project, it'll be a struct, and there's really no good reason to make it a class in this case. So next, what makes a SwiftUI view a SwiftUI view? It's conforming to this view protocol. And this view protocol has one requirement, a body property. This body property is a computed property, and it will be called every time the view needs to be re-rendered. And you'll see how that works in a moment. So we have these 2 at things here. And if you haven't seen some of these updates in Swift, these are called property wrappers. And they do some things under the hood for you to set things up for, in this case, making these otherwise normal properties be observable properties. So we have an observed object, which is going to be our view model that we're going to use to provide the data to bind to this SwiftUI view. And then we have this state property, which is going to be used internally within this view to manage, in this case, show settings. So we have the show settings that's set to false by default. When we tap the button that we see this pointing to here, that button will toggle to true. And when that toggles to true, this sheet is presented property will switch to true, which will cause the settings view to be displayed. And the thing I just want to point out here, 2 things actually. One is it is presented, it's declarative, not present, which of course is what you would see in a UI view controller API. The other thing is, and I didn't mention it earlier, the body is a sum view. That's an opaque result type, and it's sort of the opposite of a generic. So what they're basically saying with a sum keyword is that this will be something that conforms to view. The implementation will determine what that something is. So if you're not familiar with that, that's what that's doing, and that's all it's doing there. Okay, moving on. So now we're inside of the body property, and we're implementing this, starting off with a navigation view. And this is what it takes in SwiftUI to create a navigation hierarchy, right? So a navigation controller with a navigation bar and so on. Inside of that navigation view, we're going to use a VStack, which is just like a UI stack view with a vertical orientation. And this is how we'll lay out our UI elements. The first one is going to be a search bar. And this is actually just a regular UI search bar. I created this custom search bar SwiftUI view, and it just wraps that. And there are APIs that let you present UIKit components in SwiftUI. And for that matter, there are new APIs that let you do the opposite. So those exist, and we've done that a couple of times in this example code and in the project we're going to work in. So inside of that, or I should say the next item in the VStack is a list. And this is what it takes to create a table view. So you think about the APIs you've used before and having to set the data source and perhaps the delegate and so on. This is it, right? So this is all it takes. You create a list, and in this case, we're going to pass this for each constructor that will actually vend views on demand from the collection you pass to it. These are all function builders, by the way, and these are the components that build up the views that make up a SwiftUI view, as we see here. And you see the nested views and everything sort of follows suit that way. So this for each is going to vend these gists one at a time. And then inside of that, we're using a navigation link. And this navigation link is what you use to trigger a navigation, say, to a detail view. In this case, we're going to present a Safari view, which is, once again, a custom view that wraps a regular SF Safari view controller in a SwiftUI view so that we can use it within a SwiftUI view. Next, we have some view modifiers. And all these purple items that you see here are view modifiers. And what these basically do is you attach them, or I should say the view that you attach them to will customize that view in some way. They will receive the view, they will customize it in some way, and then send the customized view downstream, if you will. And so that's a lot like the way Combine works with publishers and operators. So these are two view modifiers that set the navigation bar title and then set it to hidden. And this is just a way that I found to basically hide the second navigation bar from appearing when you use an SF Safari view controller, because that has its own navigation bar. Anyway, but these are also view modifiers we see here. Setting titles, setting bar button items, setting the color for the foreground in this case, ignoring safe area insets, and even this last one at the bottom here, which is a view modifier that will present a sheet, as we saw earlier, when the show settings state property changes. And that $, by the way, that you see there is how we work with this property as an observable piece of state in this case. And that $ is just the syntax that we use, and we'll see this in code as we kind of get into this. All right. By the way, this is just I have a screenshot on my social media that you can grab of this. This is just sort of a take-home reference sheet if you find it helpful as you're kind of getting going with SwiftUI, for example. All right, as Bruce Lee said, you know, if you want to learn to swim, jump in the water. So that's what we're going to do. We're going to jump right into the code base here in just a moment. I'm going to pause out of the presentation in a moment, see if there's any questions with what I've covered so far, and then we'll march forward. But again, here's that link to download that starter project if you haven't done so yet, and you do want to follow along as we code. All right, so we're going to get started. And in that download, we see that we have this GitHub Gists project. We'll go ahead and open that up. And this is a UIKit app. I'm going to run it in a moment just to show you what it does. But essentially, we have a typical layout. This is an MVVM architecture. And we have a view controller that also has a cell because it presents a table view. And we see the view controller has, I don't know, somewhere 100 just over 100 lines of code, not too bad, but has some auto layout constraints being applied, sets up the table view in the search bar, sets the delegates, and so on. It does use this new diffable data source, so maybe if you are looking at this and you haven't worked with those new APIs yet, it might look a little different to you than using the typical UI table view data source protocol, but this is an easier way to do that at least. Secondly, we have the cell itself, which is just to lay everything out, as you'll see how this looks in a moment. And this took quite a bit of auto layout code. So this came in at, I don't know, 120 something lines of code just to design this single table view cell. And then we have a view model, and we have other components and models that make this up. But let's just run the app and see how this looks.
Are you sharing?
Oh, do you not see that?
No.
Oh, sorry. Thank you. Glad you said something. Thank you. All right. So I'm going to just back up there and I'll just cover this again. So basically, just so you get an idea of what we're looking at, the view controller has auto layout code. It uses the diffable data source APIs and delegate APIs, as well as search bar, delegate, and these types of things. The only one interesting thing here that is a custom piece is I created this debounce method that can be used to delay processing the action that you pass to it by the time interval that you specify. So in other words, if we were typing in text to a search field or a search bar, we don't want to actually fetch on every character change. We want to delay that by 1/3 of a second. That's a typical debounce type operation, and there isn't one that exists in UIKit. So this is just a quick implementation that does that for us. You'll see in a moment that a Combine has that built in. It's a built-in operator. It's pretty common in reactive frameworks. And then, like I said, we have this cell that has quite a few lines of code to just lay everything out using auto layout constraints in code. And other than that, we just have a view model and some other components like models and the typical, supporting files. So I'm going to go ahead and run the app right now. I think I already am, but I'll rerun it. Okay, and what we see here is it's a GitHub gist browser. And so essentially you just go ahead and type in here. And when you type, it'll automatically, after a third of a second delay, start searching on that username and then pull up any gists for that user. And then as you continue to type, it'll continue to search after a third of a second debounce. So that's what this does. When you tap on a particular cell, it goes ahead and loads that Safari View controller with the gist detail, essentially a web page. So nothing too fancy, but good enough for what it's meant for here. So we'll go ahead and stop that. And I do have it set that you can unmute yourselves if you have questions. So like I said, if you do have questions along the way, I realized after the fact that it's not actually easy for me to get to the chat window while I'm sharing screen. So please feel free to just jump in and ask a question if you feel it's something that should be asked now and not wait till the end, okay? All right, so the first thing we're gonna do is we're going to get rid of the things we don't need. So we actually, well, I'll stop running it. We don't need, of course, the cell or the view controller, so we'll just delete those straight away. And we'll remove those from the project. We're going to do a number of things to set everything up to use Combine. And then the last thing we'll do is actually get into building out the SwiftUI views using those Combine publishers to make things happen. So the first thing we'll do is we're going to go into the gists view model. And in the gist view model, we see that we have this fetch gist, imperative fetch gist call that has a completion handler. And then inside calls this get gists, which has a completion handler. It uses GCD to switch back to the main queue and make sure you call resume on that task. And then I just have a helper method here that is going to produce a URL. It's an optional because this might fail if, for example, the string for the username is not valid. So that would be a reason why that might be no. So the first thing we'll do here, we are going to need to use Combine. Whoops, let's go back to view model. We're going to use Combine, so we're going to go ahead and import that now. Can everyone see that code? By the way, I made this window slightly larger text. Hopefully that's visible for everyone. If you can't, okay, great, thanks. Okay, so I mentioned earlier about this observable state and how Combine and SwiftUI kind of work hand in glove with each other in that way. In order for this view model to be something that SwiftUI view can observe, we need to mark it as being an observable object. So as you start typing, you'll get the code completion, and just make sure you choose observable object. That's the protocol. You'll see there's also an observed object, which we'll use elsewhere. And this essentially will now cause this view model to publish a will change event whenever any of its published properties emit. And there's been some confusion out there about the need to actually manually call that or to subscribe to that will change event. You don't need to do that. Instead, what we're going to do is we're going to first create our first publisher. We're going to use the @published property wrapper, and this will just be search text. And we're going to set it to an empty string by default. This is now a publisher that we could subscribe to, and we can also work with it imperatively using regular getter setter syntax, as you see, as you would use any type of property. But this @publish is what makes it publishable. And now, when we make changes to this, whoever is subscribed to it will get those new values. Keeping in mind, we're not modifying this string. We are actually passing a new string to the subscriber each time because this is immutable data. Okay, next, this is just a regular array of gists. We're going to change that to also use the @published property wrapper, which will now make this something that we can subscribe to. We don't need this task at all, but what we are going to do is just model the max retries. So I'll just say let max retries equals, I'll set this to just an int for now. We'll just do it that way. Sorry. There we go. Okay. And then we will want to create this thing that I mentioned earlier, and don't worry about the errors just yet. We'll sort those all out. We're going to create this collection, what we're going to call subscriptions. And this is going to be that collection that we're going to put our subscriptions into so that when this view model goes out of scope, it will automatically call cancel on the contents of the subscriptions that are in there. And this is typically done as a set of any cancelable. You actually could make this a collection, or sorry, an array, but just as easy to make it a set. Sorry, any cancelable. There we go. All right. Okay, we're going to delete all of this code here. There is one piece that we want to save, and that is, actually it's not in this one, it's something else. We can delete this all together. So let's just get this out of the way. It's not going to compile now anyway. What we will do though, same thing with this fetch gist. We're going to do something totally different than that code. There's nothing salvageable there. What we are going to do, just for sake of being able to show a couple different ways to use different operators in Combine, I'm going to change this from being a method that returns an optional to be a method that throws if it fails for some reason, and then just returns a straightaway URL. So in that case, we're going to say guardlet URL equals components. Here we go. Equals component URL else throw. In this case, we'll just throw a URL error, and we'll just say bad URL. Okay, and then if that is successful, we'll go ahead and return that URL. That takes care of that. Okay, so the first thing we need to do is implement an initializer, because we'll need that to set that max retries. And so we'll do something else in there here in just a moment. So we'll say max retries. That's an int. And we'll set that to a default of 2, just because that way we don't have to deal with that at the call site if we want to go with a sensible default. So self.maxRetries equals max retries. And now we're going to create our first subscription. So I mentioned earlier that in order to subscribe to this, which is just a regular can be treated just like a regular property. I didn't make it private, and you might decide you want to have, say, for example, a private set on this, but in this case, we're not going to. But in order to actually work with this as a publisher, we will use the $ prefix to the exact same property name, that whatever it is. And you'll notice that when you type that $, you'll get contextually appropriate code completion with whatever publishers that you have available to you in that scope. So in this case, we want to deal with the search text. All right, next, and I'm going to wrap this to the next line, and this is a pretty typical format for writing combined code. Sometimes, we have a lot of dot completed, chained types of operations, and they just go way out to the right. It's a lot to deal with when you're trying to read somebody else's code and understand what's going on. And so because we end up having a lot of operators in a typical combined subscription, we wrap them each onto their own line, makes it a lot easier to understand what's going on. So it's just a good best practice there. So I'm going to first use this debounce operator, and we're going to say we want to debounce for 0.3 seconds. So that means that this will wait. When it receives a value, it'll wait a third of a second to see if it receives another value before it does anything. So that's a debounce. And we do need to specify that this has to happen on a specific queue. And because this is something that would be happening from the search bar that's producing this text, we want to make sure this is on the main queue. So we're going to say dispatch queue dot main. And this, of course, would be equivalent to like the dispatch queue dot main dot async, and then putting your code into the body of that and the trailing closure. This is the same thing, combined style. Next, we're going to want to use a flat map operator. And we actually haven't implemented what we want to flat map into. So I'm going to pause on that, and I'm going to comment this out, and we'll go ahead and implement it. But the flat map operator will take the value that it receives from the upstream publisher, in this case, the debounce operator, and it's going to, the documentation says transform, but I like to use the word transpose because it can be used in a couple different ways. And it's going to allow us to transpose the received value into, in this case, another publisher. I'm sort of chaining together these publishing operations in that way. So what we're going to be doing here in a moment is using this fetch gists publisher. So we'll go ahead and implement that now. And we'll call that func fetch gists for username, which will be a string. That'll be the string that it receives from that debounce operator. And then this is going to return, and we're going to see this time and again. And this is the beautiful thing about Combine. It's the same patterns and practices regardless of what you're doing throughout the SDK using Combine. We're going to be returning in any publisher. So it's going to be a type erased publisher. In this case, it's going to be of type array of gist. And there's a second value that you need to specify. And this is the type of error that could be emitted by that publisher. Not to say that it's going to, but that it could. And when a publisher is going to be designated that it will never return an error or never emit an error, it'll only emit values and regular completion events, we use the never type, which is just a marker that basically says there will never be any errors. It's guaranteed not to produce any errors. And so inside of that, we're going to use this jest constructor, which allows you to pass something to it, a single value. It could be an array of values as well, but a single value, and it will turn that into a publisher. That's all it does. It's a one-shot deal. It fires off that published value, and then it completes. It's just a one-shot deal. All right, so we have this username, which is just a regular string, but we've just created a publisher out of it. And the first thing we're going to do is actually a side effect, and I want to talk briefly about that. How are we doing on time? Naturally, when you do these things live, they take longer. So we might be going a little over an hour, so hopefully you guys can hang on, but I'll record this whole thing and make it available if you can. All right, so handle events. This is a side effect. And what I mean by that is it's an operator that it's going to receive the value from the upstream publisher, in this case, this string, and it's going to allow you to do something with that string. However, it cannot make any changes to it. So it's not like a regular operator like map, for example. You can't append that string or change it in any way and then send a new value downstream. It just passes the value through. It's just allowed to produce, to perform some kind of side effect. And in this case, what we want to do, you see when I type in REC to receive, I have several different options that I can work with here. I just want to receive output. So I'm going to do receive output. And this will allow me to get the values that are being emitted from the upstream publisher. And I'm going to make a weak capture of self here, because what I want to do is I want to take a look at if this string has a count of less than 3 characters, then we want to set the gists to an empty array. In other words, we want to make the table view empty out, and this is how we would do that. So I'll just say if the value passed in dot count, so the string is less than 3, we will just call self.gists equals an empty array, right? And so because we're just working with this as a regular property, and we're not using the $ here because we're actually setting that to an empty string. And that's all we're going to do with that side effect there. All right, next, we're going to similarly also want to filter out the values that are being received here. And we want to say that if the count of that string that's being received, the username that the user has typed in, is greater than 2, then we can proceed. So these kind of work together, don't they? This one empties out the array if it's less than 3, and this one says, okay, if you're not greater than 2, then you can't proceed. So that's what that filter operator is going to do. Next, we'll use a try map. And this is where I changed the implementation of the URL for, just to show you this. Try map is going to allow us to pass, in this case, we're going to match the function type up, URL for. Let's use Control-I to go ahead and re-indent that. So this try map is going to, the function types match up, and so this will take that string, pass it to this parameter for this URL for method, and it is going to throw if there's a problem, so that's why we're using the try map as opposed to a regular map operator. We'll deal with that error that could be thrown here in a moment. So next we need another flat map, and this time we're going to flat map to a publisher that we haven't created yet, so we'll once again just pause on that, comment it out, and then implement it. So what we're going to create is the actual publisher of gists that this will be flat mapped into to produce the array that this publisher this fetch gist will make available, if that makes any sense. So once again, we'll do func, and we'll say gists publisher for URL, should be of type URL. And once again, this is going to return in any publisher of type gists, array of gists, I mean. But this time it will actually emit an error. So the error will be from the URL session that we'll see here in a moment. And so we're going to have this return an error, just generic here. Just it's going to be of some type that conforms to the error protocol or adopts the error protocol. All right. So I want to pause here for a second. If anybody has any questions about what I've covered so far that need to not wait till the end, that's totally fine. Feel free to ask them. And while you're thinking about those questions, I'll also mention that I might have decided that I'd just do this whole thing in line in one big subscription. You'll find, and this can be a point of frustration when you're getting started with this, that when you try to do that, there's a challenge to line up the input and the output of each publisher and each operator in that chain. And what I'm showing you here is a handy way that you can sort of split apart your logic and avoid some of those problems. Because what we're doing here is we're saying we explicitly want to just receive this URL. We're ignoring any possible errors, and then we're going to publish this. We're going to return this publisher that will then be inline and emitting downstream. So if you were to play around with this code once we're done and try to move this all into one chain and not split them up like this, I think you'd have a better understanding and appreciation for how this really sort of saves the day for you, makes things not only a little easier to follow, but also avoids having to deal with some of the inner workings of how Combine works with lining up input and output requirements. So we have this gist publisher, and we're going to do this URL session, and we're going to use the shared version of that singleton. And you'll notice that we have data task. We knew about that all along, but now we're going to use this data task publisher, which is a new API that will return a Combine publisher for the data task instead of an imperative data task with completion handler. And so what we want to pass through here is the URL that is the parameter for this method. And then we're going to use the max retry. So we're going to say if there's a problem with this fetch, maybe there was a timeout on the network call or whatever, we want to go ahead and use that max retries property to automatically retry that fetch. That's how you would do that. If you've seen, you know, the imperative approach to this would be a little more elaborate, might even involve some recursion or something like that. It's just this tiny little bit of code to do that in Combine. Next, we will use the map operator and the newer version of map that can work with key pass. And we're going to map to, let me back up here. You'll notice that what is returned from this data task publisher is a tuple that contains the data and a response. We just want to work with the data right now. So we're going to map to that data. And then we're going to use the decode operator. And the type we're going to decode to is going to be array of gist. So we'll just do gist array.self. And we'll just use a JSON decoder here. All right. The last thing we're going to do, if we were to leave this, this would actually be a different type of publisher. And if you option click on decode, you can see the kind of signature, the function type that the return value is, and it's pretty hairy. And so the best practice that you'll see pretty consistently and that you should really adopt for yourself is to always erase your publishers to erase them of type. So it's called type erasure. And not only does that clean things up and provide for a consistent and expectable API, but it also prevents callers from being able to reach into and have any knowledge about or manipulate any of the details of that publisher. So that's less the case here, but there are types of publishers in Combine where if you didn't do that, it might be possible for the call site to actually add values onto that publisher, which is probably not what you want. You want it to be subscribe only. So any publisher is a way that you can hide those implementation details and prevent that. So how do you get an erased publisher? You just do erase to any publisher. And so that's sort of the end part of each of these publishers that you're creating. And we're not creating a subscription here, we're creating a publisher, right? So you'll see the subscription that we're creating up here in a moment and how we handle that. So now that we've got this gist publisher, we can go ahead and uncomment this line where we started the flat map, and we can just go ahead and pass that gist publisher for inline. Yep. Okay, so we're flat mapping the value, which is the URL, into this gist publisher, which happens to take a URL, and it returns a new publisher. And now we're going to be working with this new publisher that will emit either an array of gists or an error. So the next part of our flat map or of our operation here for the publisher is we're going to do some really lightweight error handling. We're going to just say if we get an error, we're just going to replace it with an empty array. We're not going to, just for this simple example, we're just going to go ahead and do that. So this would say if we get any error, that error could be from the try map operation. It could also be from this gist publisher. Either one of those could produce an error, and we're handling it here in this single line of code. Simplistic, but at least you get hopefully a good example of what that looks like. As with any data task events that are occurring on URL session, any of those APIs, they automatically go on a background thread. And so what we're doing here is we're going to need to say receive on, and make sure you choose the receive on version, not the receive subscription or subscriber. And we're going to receive on dispatch queue.main. And this is putting us back in the main queue so that our subscriber doesn't have to do that themselves. Just a convenience thing. And the last thing is erasing this to any publisher. Okay, so now that we've done that, we've implemented this fetch gist that then transposes through a flat map into the gist publisher, and ultimately we're working with this publisher downstream, and that's what we're going to subscribe to here. So in our debounce, after our debounce, I mean we're going to flat map into the fetch gists. Code completion, where are you at? There we go. And that takes care of that. Now you have to be careful. If they were doing anything here that was capturing self, we would not be able to do this nice inline parameter type of approach matching up the function types here. We'd actually need to do, implement the trailing closure syntax and do a weak capture in most cases, right? This is just a convenience because we're not actually capturing itself, so we don't have to worry about any type of strong reference cycles by taking this approach. And by, again, implementing things in this way, it makes for really clean syntax that's easy to follow after the fact. So we've got our flat map, and we've got this fetch gists, and we're going to get that publisher that comes back, and we're going to map that. And in this case, we want to use the sorted by operator, and we actually do need to implement this as trailing closure syntax because the function types don't actually line up. So sorted by, and we'll just say we're sorting by descending. So now we're taking this array that comes back, and we're just going to sort it in descending order using that map operator. And then I mentioned earlier there are two operators that you can use to create a subscription. One is called sync, and that very similar to that handle events we saw earlier, except for it allows you to either receive the completion event and or receive values that are emitted from the publisher, and that's how you create a subscription. Here, though, we're going to use a different one. We're going to use assign to, and assign to takes a key path. So we're going to say we want to assign to the gists property on self. So that's going to take the value that comes back, sort it, and then assign it to gists. And now that gists value will then be published to subscribers. So the last thing we need to do with this assign, and this is the thing that you need to do with all subscriptions. Either you want to say, let my subscription, equals that value. And of course, if we did this here, it would immediately go out of scope and the subscription would be canceled and you'd leak that memory. But you can either assign a subscription to an individual property like that, whether it's a value like a local value or a property on the type, but more often than not, you'll just do store in subscriptions, and that will automatically add that subscription to this collection, and it will be canceled whenever this view model goes out of scope. And the final thing I'll mention about this is that the view model does need to be, or I should say an observable object does need to be a reference type. You would not be able to make this a struct. So it's something to be aware of. All right. Yeah, I'm way slower than I was in practice on this. So I just want to let everyone know that this is going to go over an hour. Hopefully you can stay on. If you can't, I totally understand. Okay, so the next thing we're going to want to do, though, is we're going to take a look at this cell view model. And you're going to see some of this is very much a rinse and repeat kind of thing. We want this to be an observable object. So the first thing we're going to do is import Combine. And we're also going to change this to import SwiftUI. Next, we will mark this as being an observable object. And we're going to use Publisher to get the avatar image. So if you remember from the app, when we have a URL for that gist owner's avatar, we're going to asynchronously go fetch that on another publisher, and we'll implement that in a moment. But for right now, we'll create a publisher of that avatar that it can automatically be used to bind to that image and be updated when the image comes back. So published var avatar image. And that will be this SwiftUI type, which is an image. And we're going to use the system name to start out, and we'll just use a placeholder, which is going to be a person.circle.fill from the SF symbols library. And that'll just give us a nice little placeholder avatar that we can use. Everything else we can leave here, except we don't need the tasks. And instead, we're going to need the subscriptions array, subscription set, I should say. So we'll go ahead and implement that now. Okay. All right. And then we'll get rid of these. We don't need these. We're going to do these in a different way. So we'll get rid of these altogether. We're not going to be canceling tasks or creating tasks using the existing implementation, the imperative implementation. Instead, we're still going to set the gist on this cell so it can be used to update that UI. And then we're going to once again create a publisher from that gist, just passing it to the just constructor. We're going to map. And this time we're going to use the key path to go to the owner's avatar URL. And so this gist, if we just jump into the model definition of gist for a second here, we see that it has an owner property. And in that owner property, it has the avatar URL. So we're just using dot notation here, dot syntax, through the key path to reach into that gist's owner's avatar URL. Then we're going to flat map, and we're going to flat map to a new implementation for the remote image service that we haven't done yet. So once again, we'll pause here. We're going to go to the remote image service. And in here, we're going to keep most of this implementation. We are, once again, going to switch this to import SwiftUI and then also import Combine. We'll jump down just below the private initializer because this is a singleton. And we'll add this avatar publisher in place of everything here. The only thing we're going to keep is this code here. We're going to change it a little bit, but rather than rewriting it, I'll just grab it. I just copied it before I delete all this. So I'm going to delete this. Well, actually, I'm going to keep that resize method as well. We are going to continue to resize just to be, as memory efficient as possible. But I got rid of that existing method, and we're going to create a publisher instead. And again, this is just rinse and repeat. We're going to create an avatar publisher, and this will be for URL that you pass to it. And guess what? It's going to return in any publisher of UI image in this case, and never. We're going to handle the errors internally. We're not going to pass an error on to the call site, to the subscriber. All right. So there's a cache, and all we're doing with this cache is we're saying if the image has already been fetched, cache it, and then just reuse it rather than fetching it every time. So just being good, memory and battery and all these other things, being cognizant of that. So we'll paste this in here, but there is no completion handler anymore. So instead, what we're going to do is if that image does exist in the cache, we're just going to return, using that just constructor, that image and erase to any publisher to match the signature. Pretty convenient. All right, presuming that that image hasn't been fetched yet, once again, we'll have to return here. Return URL session .shared .data task publisher for URL. Right, same kind of thing. So retry, and this time we'll just manually do this 2 times. We don't have a property to pass in there. We're going to map to the data. We're going to use a compact map operator this time because we want to pass this data to the UI images init. And this UI image takes data and it returns an optional. So we're using compact map to filter out if it returns nil. If the initializer fails, it'll return nil. And so we're filtering that out with that single operator, just like compact map in the standard library. And then we're going to use another compact map operator, this time implementing the trailing closure so we can get a weak capture of self. And we're going to use that resize. So we're going to self.resize, and we'll just pass in the default argument name. Okay, so that's just calling over here and returning that, UI image resized. And the reason why it is compact map is because we're not guarding for self being nil here. We're just using it that way. So the last thing is we're going to replace the error. And we're just going to use a regular UI image, once again, using the system name being the person.circle.fill. And I'll need to force unwrap that. We know what we're doing. So we'll just go ahead and do that. I want to make sure that this goes back onto the main thread. I'll just open this up as a question. How would I go about doing that here? How would I make sure that this is put on the main thread for the subscriber? You should be able to unmute yourself if you want to ask. And if you don't, I'll wait about 3 seconds and I'll just answer it for you. So we want to call the receive on operator like we did before and just use dispatch queue.main for that purpose. And then last thing, erase to any publisher. All right. So now we've got our avatar publisher, which will go ahead and publish the image once it comes back. And so we can subscribe to that and update the UI, we can subscribe to that, bind that to our SwiftUI and image, and then that will automatically update when the data comes back from that publisher. All right, so let's go back to our cell view model. And in here, we're going to continue on. We have that flat map, and we're going to flat map into the remote image service .shared .avatar publisher 4. Okay. Then we'll map, and we're going to map to this image initializer, which doesn't return, it doesn't return an optional, so we can just pass it straight away. Oh, we need to add one more parentheses there. There we go. And then we'll receive on, this is a typical thing, it's receive on dispatch queue.main. That might be unnecessary because we already did that in the remote image service, but I like to be, this is just a little bit of defensive coding here, making sure. And then we'll use the assign operator again to assign to the avatar image on self. And lastly, want to store that in the subscriptions. And you'll notice that the storing method uses the ampersand to dereference, because subscriptions, of course, is a set, which is a value type. And of course, by using the ampersand, we can dereference that and make sure we're adding it to the same set as opposed to a copy, which would be useless. All right. So that actually takes care of both our view model and our cell view model. We have a couple other changes that we're going to want to make. First of all, in the actual model for the gist object, we're going to be passing this using that for each constructor that we saw in the slides earlier. And in order for that to work, without having to do some extra implementation at the call site, we just need to mark this as identifiable. And identifiable has a single property requirement of ID, which we'll just set to a UUID, and be done with it. That's all we need to do there. All right, next I'm going to actually start to create the SwiftUI. Then we're going to circle back and make a couple other changes, and then we'll be done. And we're probably going to be about, I'd say, 5 to 10 minutes, and then a couple of more slides and some questions. So we might be wrapping up at around 1:15. Hope that's okay for everyone that can stick around for that. But again, this will be recorded if you can. Okay, so next we're going to just right-click on Views, New File. And this time we'll just go ahead and say SwiftUI View. And we'll call this Content View, primarily because when you create a new SwiftUI project, that's the first view that gets created for you automatically, and it's just sort of a convention. You name it whatever you want. You'll notice that this is a very simplified version of that anatomy slide that we saw earlier. We've got a content view, and it has a single body property, and it just returns a single text of Hello World. This is the proverbial Hello World app in SwiftUI. And that's good enough for now. We're going to, of course, come back and change that momentarily. But the first thing we want to do is in Scene Delegate. Right now, we've got an implementation that is based on an imperative approach. We're going to make some changes to this, but I want to point out that when you do create a brand new SwiftUI project, this will be automatically implemented for you. So we're just going to kind of do some boilerplate here that is necessary to set this up correctly. So the first thing is we're going to make sure that we get this window scene from the scene object, else we'll return. We'll get rid of this. We're going to create a window by using the UI window initializer that takes a window scene, and we'll pass it the window scene that we just received. All right, so next we're going to now create, I'm going to just hit some spaces here. Next we're going to create a content view. This is going to be that content view that we just created, that SwiftUI view. And we can delete all of this. And we're going to say window root view controller is going to be a UI hosting controller. Let's see, hosting controller. I don't know why that's not giving me my code completion. Let's just make sure. Oh, you know why? Because we have to import SwiftUI. Let's just do that right now. There we go. There we go. Okay. So this UI hosting controller has a root view, and we're going to pass it the content view. We do have the make key invisible, and then just to make sure that we don't lose that window when we go out of scope here, we're going to set self.window equal to that window that we instantiated in this method. Okay. Next, we're going to jump into app delegate, and I'm going to just make one change, which is somewhat of a workaround. Okay. So there's a couple things here. When we create a list in SwiftUI, the edge insets are the typical ones that you'd see for a table view, unless you manually change that with the property on the edge insets property. And so that doesn't exist in SwiftUI. That API does not exist. And so one way that you can go about getting the same effect, if we wanted to, for example, not have an edge inset on our separator for our table view, is to just use the UI table view appearance proxies. So UI table view dot appearance dot separator inset equals 0. Okay, another one is that when you tap on a row in a SwiftUI list, and that might even segue to a detail view, if the keyboard was presented in the case where you tap into a search bar and type some text and then tap on a search result, when it comes back to that list view, it'll actually represent the keyboard. In other words, there's not a way to imperatively say resigned first responder in SwiftUI. I would be certain to know that this will be updated in some, by WWDC or some point thereafter, But for right now, what I found is an effective way to handle this is to use an appearance proxy on scroll view appearance dot keyboard dismiss mode. And there's a couple options here. I'm going to go with the on drag. So this just means is as I drag on that list, it'll automatically dismiss the keyboard, and then it won't pop back up whenever I might go to the detail and come back again. So it's a convenience capability there. That's all there is for the app delegate. Okay, now there are several views that we're going to want to create here, but what I'm going to do, because we would be here for another half an hour if I didn't do this, and even with these helper files that I'm going to show you how to get, we're still going to run a little bit over. So if you go into your download where the GitHub Gist start folder, and if you don't see anything else here besides the GitHub Gist folder, do Command Shift period, and you'll see a hidden folder there called SwiftUI. And inside there, we have a Gist view, we have a Safari view, we have a search bar. We're going to pull these in and just drop them into our views folder, and we'll take a quick look at them, we'll use them, and then in Q&A, if anybody has any questions, we can certainly circle back and spend as much time talking about them as you'd like. So make sure you copy items if needed when you add these to the project so that you're not dependent on an external link. All right, so what we just did is we created this Gist view, and this is a pretty straightforward view. If you haven't worked with SwiftUI before, it'll feel a little overwhelming at first. Again, we're not going to spend a whole lot of time here, but this is just using a series of V stacks and H stacks, horizontal stacks, and the avatar image that we created the publisher for to be able to lay out that cell essentially, right? That view that each row displays of all the content for the gist, including the avatar and the title and last updated and all of that. Secondly, we have these two other things. We have the Safari view and we have the search bar. Search bar is a UI search bar wrapped in a SwiftUI view. And so it uses this API called UI view representable. And that is actually a protocol that requires you to implement this make UI view and this update UI view. And I'm kind of going through this pretty fast because again, this is a little slightly more advanced stuff, but I want to be able to use these to convert this app from UIKit to SwiftUI, and this is how we would do that if in fact we wanted to use a search bar. So I've implemented the make view that literally just creates a UI search bar instance, sets the delegate, some placeholder text, and returns it. An update view, we're just taking the text and we're updating the UI views text. So anytime that needs to be updated, that's how that will work. The delegate, just to be clear, needs to be set to something so that we can respond to when the delegate methods of the UI search bar text delegate, UI search bar delegate. So in order to do that, we have to implement this thing called a coordinator. And the coordinator allows us now to respond to texted change callbacks and the search bar search button clicked method callback for the UI search bar delegate. Again, throwing that out there, just the takeaway here is that using UI view representable when you want to wrap a UI view in a SwiftUI view. And if you need to do that, you can certainly use this, this code here as an example of it. Or if you search the interwebs, there's lots of examples out there as well. Similarly, Safari view is actually a UI view controller. So we're using UI view controller representable, which has a make UI view controller and an update UI view controller. And because we also want to set a delegate here for that coordinator so that when you tap the done button on that Safari view controller, it'll dismiss it. We're using this coordinator context again with something called a presentation mode that lets us dismiss it. Again, Q&A if you have questions about that, or after the fact, you can always hit me up on Twitter or wherever, and we can certainly address it. But this is the implementation, not too many lines of code, but this is how we would wrap a view controller with a delegate in this case, and wrap this in a SwiftUI view. So back to the content view here. So the first thing we want to do in this content view, and this is actually a pretty light amount of code for what we're going to accomplish. We're going to get rid of this text, and we're going to say navigation view. Oops, navigation view. Right, this is going to be very similar to that slide that we looked at earlier. And then inside of that navigation view, we're going to do a V stack. Okay, and then inside of there, we're going to do a search bar. And that search bar is going to have text. And that text we're going to bind using the $, because we're going to basically bind this to the subscribable publisher view model dot search text. And of course, we need to implement that view model in order for that to work. So we'll come up here, and right inside of the definition of this content view, we're going to use that other side of the observable object that we saw earlier, that protocol. We're going to use the @observed, and make sure you grab the ED version of that. That's a property wrapper, and that will be our view model. And we'll set that to an instance of the gists view model. And so now this is the observable object that we can then use the $ to bind to in this case. So we have the search bar now bound to that value, which means is as the user types text into that search bar, that text will be sent to this publisher, this search text publisher, which if we remember, will be received here, debounced, flat mapped, sorted, assigned to the gists, and that's it. That's how that works. So the next piece, now that we've got a way to have the user provide that input to kick off those fetches, is to create a list with a for each constructor, and we're going to pass the view model's gists. And in this case, we actually work with the regular value here. This constructor, this initializer for the for each takes a regular value, not a binding value. So that's what we pass there. And do you need to memorize that? No. If you try to use a $, it'll give you an error, and then you'll try deleting the $, and it'll work, and you'll move on. So the for each has a trailing closure. We're going to just give that argument a name. So we're going to say gist in, and then we're going to use a navigation link, which remember is how we segue to a destination. And our destination is going to be Cancun. No, it's going to be a Safari view controller. It's a Safari view, actually. And that's the SwiftUI view that I just showed you the implementation of. And that's going to take that URL, and that's going to be the gists. And it has a property called HTML URL. All right, so we're going to add, and don't worry about these errors here, they'll go away. We're going to add some view modifiers to this navigation link. And you'll see we've got this closing parentheses here that is actually part of that inside that navigation link. We want to add something to the Safari view. So we're just going to hit return there. And now we can add a couple of view modifiers to the Safari view. So we're adding to the Safari view here. And the first one is the navigation bar title. We want to set this to an empty string. And I'll do it first, and I'll explain it in a moment. And then we're going to say the navigation bar hidden is true. What's happening here is this. I have found, and you can comment these out and run the app, and you'll see that when we present a Safari view using SwiftUI, Safari view has its own built-in navigation bar, and then SwiftUI will automatically want to create a navigation bar for it as well. So there's literally be two stacked vertically on top of each other, and we want to avoid that. And so the way that I found to effectively do that is to set the title to an empty string and then hide it. And I did need to do both, but having done so, that would take care of hiding it for you. So I'm going to just rewrap that closing parentheses back up to there, because that is the end of our implementation of the parameters of the navigation link. And the last thing we'll just do here is we will implement the trailing closure. And inside of there, we're going to, this is the content that the navigation link will contain, right? And that's going to be the whole view itself, the cell essentially, the view that has the avatar and all that. And we're just going to pass the gist that we have from the for each into that. Almost done. So the last thing we want to do here is we want to add to the end of the VStack. So we'll go to the VStack here. And if you just kind of hover over that or hold the command key, you can see the closing ones down here. Right at the end of that, we want to say the navigation bar title for the screen that we're on, the list screen essentially. We want to set that to just something like GitHub gists. And then we're going to ignore, because we want this list to actually expand to the very bottom of the screen, ignoring the safe area. So we'll say edges, ignoring safe area, and we'll choose the bottom. All right, almost done. The last thing I want to do, I mentioned earlier that in the scene delegate, in the app delegate, we implemented this appearance so that when we drag on the list, it'll automatically dismiss the keyboard. It'll basically call resign first, responder first, and dismiss the keyboard. What we want to do here, though, in the content view is implement a way that if you tap on a row, that will dismiss the keyboard too. Again, that would be sort of an imperative thing, right? Resign first responder is an imperative method. It's something it's an action you're saying, here's what I want you to do. And that is not very declarative. There isn't a way to do that in SwiftUI right now that I found. So I'm going to just once again rely on an extension here, in this case to UI view. And what we're going to just implement here is the touches began method. Began, super touches began with touches and event. And this is just a little bit of helper code that you can use in your projects that will allow us to essentially resign that first responder when somebody taps on a view within your SwiftUI view. So UI application dot shared. We deal with potentially multiple window environments. So we have windows. We want to get to the first one where that is the key window, which is an optional. We're going to use this fancy unwrap type of optional operator here to do that. And then we'll call end editing on it. Oh, not in code, but end editing true. All right, that is that. So let's just make sure this builds. Hope we don't have any errors here. Wonderful. Let's go ahead and run the app, the SwiftUI and Combine version of this app. And voila, type in some username and you get the same output. And when we tap on the row, we get the Safari view controller presented with that particular gist detail. Okay. I've got a couple of slides just to wrap up with. Then I will stick around for questions for as long as anyone would like to ask them within reason. Okay, first things first. If you want to download the finished version of that project, you can just use the same URL as the starter project, appending -final to it. Let's see if I have some questions here. And if anybody has any questions, feel free to jump in. Okay. I'm going to do a quick retro on this. So if we were to do a character count, and I chose character count because, as you might have noticed, SwiftUI and Combine not only require less lines of code, but also it's less dense, right? It's thinner code. You write less code. And so the way to really accurately reflect that is to count both the lines and the characters, or in other words, just the characters. So if we were to look at the character count, not including comments, for the original app with UIKit and traditional APIs, it would come in at just over 18,200 characters, okay? Not lines, but characters. But still, if we were to do the same count against a modified version of this code base, minus and comments, we'd be about 4,000 characters less. And that represents roughly a 20% savings, a little over 20% savings in the amount of code that you write to do that. So it's interesting. And t-shirt representations of those numbers, just to give you a visual. Okay. If you want to learn more, there's a book out there that I happen to be a co-author of, and I was a tech editor for, called Combine, Asynchronous Programming with Swift. This does focus on Combine. However, there are some chapters, including the final project of the book. I wrote that final chapter, and I used SwiftUI and Combine to create a Chuck Norris jokes app, which I think is a good example, and it includes unit tests and everything else. So it's really a comprehensive tutorial on using SwiftUI and Combine at the end of that book. There's also a dedicated book to SwiftUI. Both of these are by the Ray Wenderlich library. There's some short links to get to them if you'd like to buy those and learn more about these two frameworks. But I've got a couple of questions and I've got a couple of giveaways for the first person that answers this question. Whoever wants to answer this question first, literally by unmuting and asking and giving me the answer, will be the one that, if they get it right, will get a special prize.
Published.
Who said that?
I did, Matthew.
Matthew.
Yeah.
Okay, Matthew. I believe you can send a message in the chat or email me or stick around after we wrap up, and I want to get your contact info. I will give you a copy of your choice, either a copy of the Combine book or a copy of the SwiftUI book. Both of them would be a PDF. I'll just basically have a link sent to you so you can download your free copy.
Awesome. Thank you.
Okay. I got one more question, and it's the same thing, so everybody get ready. I've been watching Better Called Saul, and right now he's doing the bingo events for the old folks home, and I almost feel like him right now with that mic. Here we go. Okay, so it's published. What view type triggers a navigation when pressed?
navigation link.
Who said that?
That's me, Christoph.
Okay, great. You're absolutely right. So hit me up after and let's get your contact information and I'll get that link sent to you. Just let me know which one you want, Combine or SwiftUI. Okay?
Cool, thanks.
Yeah, thank you. Okay. So I'll pause for questions here. And if you need to jet, that's totally fine. But any questions that anyone has about anything I covered, we can jump back into the code, look at some of those views that I brought in from the downloaded resources, whatever you'd like. Anything from anyone? I'll stop sharing my screen.
Scott, I know you had to do some interesting stuff for like Touches Began. Are there anything that you ran into in either SwiftUI or Combine during this project that you weren't able to get around?
Great question. I don't think so. You know, I generally try to find a reason to get myself into trouble and then refuse to give up and just get myself out of trouble. So yeah. the touches thing was an interesting workaround. I tried a lot of different things, not with this particular project, but I spent literally an entire Saturday morning. You can probably jump on my Twitter feed and find the conversation. It was a few weeks ago. There was a guy who said, all I want to do is have 2 text fields. So SwiftUI simplifies a lot of things, but there are some simple things that you could have done very easily using some constraints, for example, that you can't very easily do in SwiftUI just yet. One of them was he wanted to have basically 2 text fields and 2 buttons where the buttons were equal width and the text fields were equal width. So like basically 2 rows essentially, but not in a table view, just on a regular view screen. And I tried everything under the sun, and I was just hell-bent on making sure that this could be done in SwiftUI, and I didn't believe the person who had said, here's how I had to go about doing it. And I posted screenshots of my different tries and everything else, and the playground or a SwiftUI project to demonstrate it, and I wasn't able to do it. So what the quote-unquote right way to do it is to use these things called preference keys, which will allow you to reach back and it's sort of an imperative thing, reach back and obtain and set values like width, for example, as the screen is being rendered. So that was just not with this project, but that is something that I hit along the way that I found, you know, there's definitely an opportunity for that to be improved upon in this next, you know, dub probably.
Awesome, thanks.
Yep. Any other questions? Don't be shy. If you got it, somebody else has it too. So Hale, I know you have questions. You always have questions.
Hey, Scott, there are some questions in the chat. I don't know if you can get to it or not.
Oh, there they are. Thank you. Thanks, Dave. Okay, let's see. Is it correct that, thank you, Dave. Is it correct that Combine is forcing to use functions with throws, but not result type? No. Well, so remember that a publisher is either going to emit some error type, which has to be handled, and that could be emitted just by way of returning that error or throwing, if it's a throwing method like that try map operator. But what is returned, for example, from the data task publisher is not a result type. It's a tuple that gives you the response and the data. So that is the actual type that you get back from the data task publisher. If you, for example, wanted to work with a result type, you wanted to say inject, this is something that I'm doing in my work, my daily work now, where we want to basically take the fact that a data task may complete successfully, but the status code of the response was invalid in some way, and it's still basically an error. You could use a map operator to map that into the result of success or failure of type and use your own logic to interrogate that status code for the response and determine if that should be treated as an error and throw one as such. I'm doing that right now in a sort of centralized error manager implementation at Wayfair. Is adding a cancelable to the subscription array equivalent to Arc's dispose bag? Very similar, it's just a better name. Yes, it's the same concept. You're basically managing the memory for that subscription by way of passing it to a collection that can then take care of canceling that subscription for you when the enclosing type goes out of scope. It's basically in D init. Oh, sorry. There were people that were typing in the answers and I couldn't see them. So that's why I reverted to the audio. I don't know why I wasn't able to see that. That was interesting. Let's see. Copy of the video. So this will be, this is being recorded and it'll be published within an hour or so after we finish up here. And I'll just go ahead and put that on my Twitter. So if you just jump on my Twitter, it's Scott EG. That will, you'll see that and you can watch it after the fact. Thanks for the feedback on the book and any other questions or, you know, any adulation, I'll take that too. Kidding. All right, then that's a wrap. Sorry, this went a little long. I've done this talk already a couple times and I was able to stuff it into an hour. Don't know how, but today we ran a little long, but I wanted to make sure I got through the content for all of you. So I really appreciate you joining me. And like I said, if you have questions after the fact, don't be shy. I'm available on Twitter. If you do the LinkedIn thing, that's there too. And I will probably post this project up to the finished version of this project up to my GitHub as well at Scott EG at GitHub. So you'll have access to that there as well. But if there are no other questions, I'll go ahead and end the session now. On Friday, I will be doing a 3.5-hour workshop that will be building a chat app using SwiftUI and Combine. And it will include translation and it'll include some customizations of things like a reversible scroll view and that kind of thing. And that will start out with, actually it's the same slides. So if you've attended today, you could show up late for that talk and you wouldn't miss anything because it's literally the same slides. I want to just provide that basic introduction to Combine and SwiftUI and then jump right into the project. It'll be 3.5 hours long and we'll be taking, you know, breaks along the way, 5 minutes here, 10 minutes there, but we'll get through building a complete app using SwiftUI and Combine from scratch, file new project to the finished product. So if you can join me for that, great. That will also be recorded. So if you want to watch it after the fact, but you can't ask questions to a video. So if you want to join, there'll be Q&A and some giveaways at the end of that one as well. And with that, I want to thank you all again for joining me. Hope this was helpful. And I will hopefully get a chance to talk with all of you at some point.